Radhe Radhe everyone. Our today's Leetcode problem of the day is maximum fruits harvested after most K steps. So what question specifies is, let's say you are standing here and you are been given fruits array. What this represent is at position 2, when you harvest you get 8 amount. At position 6, if you harvest you get 3 amount. At position 8, when you harvest you get 6 amount. So you have to maximize this harvesting, but the limit is the number of steps you can move. So let's say if you want to take this 3, you'll have to move one step, which is from 5 to 6. If you want to harvest this 6 amount, you have to move from 5 to 8, which is 3 steps. But yeah, when we are moving from 5 to 8, you will obviously collect this 3 as well to maximize the harvesting. And if you have to move to 6, so that's one step 3, and then you want to move to left, then it will be one step back and then 3 steps here. So it becomes 1 plus 1, which is 2, then 3, which is 5, and it exceeds your limit, so you cannot do that. So this was the example, and for here, like the maximum is 9. What you can do is go one step left, collect 3, then take 2 more steps, you get 6. You cannot move further right because there are no more fruits to be harvested. And from here, if you try going left, it exceeds your limit, so you cannot go. So maximum here turns out to be 9. So this is the solution. So whenever like this question is given to me, let's say, so I'll think of like since a person can go left, can go right. So I'll start with a recursive solution. Like from each point, the person can go left, can go right. So I'll try to go left, I'll try to go right, and the current position, whatever it has, and I'll try to calculate maximum value like from whatever it gets from going to left or right. Mm, that is what I'll come up with as my first solution. uh, and we'll see like what time complexity it can bring in. What we need to keep in mind is this time constraint, like the scale, the limitation on steps is 2 into 10 to power 5, and the positions can also range from 2 into 0 to 2 into 10 to power 5. Let's start with a recursive solution and see like how the solution works and where it might fail. So let me I will do is I will convert this 2D array into map of position and amount. I'll call it as fruit map. So this you can populate. This will correspond to position. This will correspond to amount. Why I have done is when I'll write the recursive function that this will make things clear. And from here I'll call our recursive function. I'll pass fruit map to it. I'll pass the current position. I'll pass the steps left. And whatever it returns, I'll return from here. So this is the overall function. Now let's define our recursive function. It will return int recursive. It will be map, then the current position, then the step left. We'll write the base condition. Like if step left is 0, then we will return from here fmap dot get or default uh, current position, whatever amount is in the current position. If current position is, let's say, invalid for some case, then we will return 0. Now this is our base case. Now let's try to take where we are standing. So at least that amount we can take. I'll call it as current amount, C amount, fmap dot get or default of current position 0. And from here I'll try going left and try going right. Whichever returns me the maximum, I'll take and add it with my current amount, and I'll return like whatever maximum sum is. So let's call it left amount is, I'll call this function again, pass the map. Current position will be -1 since we are going left, and steps left has to decrease by 1. Now, if we try going right, current position will increase since we are going on the right side. The steps has to decrease. Now, after these are done, what I'll do is I'll return current amount plus whichever is max out of left amount and right amount. And this is what our function looks like. So if you see the time complexity of this solution, when you're standing at each position, from each position you can go left, you can go right. So number of position is uh, 0 to 2 into 10 raised to power 5, right? And from each position you can go two ways. So time complexity turns out to be big O of 2 into positions, which is big O of 2 into 10 to power 5. Let's say if we ignore this 2. So approximately this turns out to be big O of 2 into 10 to power 5, which is 2 into power 10 to 2 raised to power 10 and raised to power 5. So 2 raised to power 10 itself is around 1024. It's 1024. So let's approximate it to 1000. It turns out to be it is 1000 to power 5. If I do it 1000 to power 5, it becomes 5 into 315, which is 10 raised to power 15. Now, this is a way bigger number to get executed on Leetcode, and it will for sure give you time limit error, time limit exceeded. Uh, what we can do is, since we have written a recursive solution, we can memoize it and do DP solution, and after that we can do bottom up as well. But let me give you some explanation like that will also not work. Reason being, you see, if for writing memoization code, what we can do is we will have to have 2D DP, because you see this 2 is something which is changing in each iteration. So if we make a 2D array, or we can create a hash map as well, a key would be combination of current position and steps left, making it as a string, and then storing an integer like whatever value it has to return. So both ways it's possible. Uh, so even if we make it as a 2D array, so you see position, so it will be big of position into steps. For memoized solution, will be go of sorry, not to we go of position into steps possible. So this position is fine, 2 into 10 raised to power 5. The steps possible is twice of the position. This steps possible is twice of the position possible. For example, let's say if you're standing at position 100 and 5 steps are allowed, so you can go 5 completely to the left, so it gives you 5. You can go 5 completely to the right. So it gives you extra 5. So 5 plus 5, it gives you 10 possibilities. So, and k can range till positions. That's what is given in constraint. So it will be twice of positions. So if I do it, so this becomes twice of position. So which is 2 into 10 to power 5 into 2 into 2 into 10 to power 5. So if you see, this is again going to exceed 10 to power 9, and then it will give you time limit exceeded. So you can code this up, the memoized solution, and this is something which people will come up when you see this problem, and this is actually hard because of its constraint that you cannot use this recursion and memoized solution. Even bottom up will not work because that will also be big of position into steps possible. So there is one more optimization. What we can do here is, you see current, what we are doing is we are doing current position minus 1 and current position plus 1. So it might happen like for minus 1 there are no fruits available, and we are given fruits array, so we know like, and it is sorted by position. So we know like if we are standing at some position, what would be my next left where I can find fruits, and then we can see whether it's possible within the given limit of steps, right? But then we'll have to take care of the steps left also accordingly, like how much you need to reduce from current one. You can do that, but in worst case, it will still be this. But at least if you think on this line, it will give you some kind of intuition, like what we can do. The fruits array is sorted. You can go left, you can go right, and steps should be within the limit. So what this gives me an idea of is, what if we can try to do two pointer sliding window kind of thing? But it won't be a very straightforward sliding window. I'll tell you like why. Let's say, let's say you are standing at this position and k steps are allowed to you. What you can think of is, if you go all the way to the left, how much left you can go? Either k, or if k is bigger, you will go on the negative side of the axis, which is not allowed. So what you can do is, whatever is max of your current position minus k or 0, this will be your left bound. And on the right hand side, what you can go is, from current position till k you can go, but what if it crosses your right boundary? And that won't be the case because the problem statements specifies like it's an infinite x-axis. But still, like, you have the fruits array, so you know like the what is the last position where your fruit is available. So what you can do is, you can do this, comma fruits last index, wherever it is available, I'll call it as r. So whatever is minimum of this, so your window should arrange between this left to this right. This could have been correct in a normal sliding window question. But why this won't work here is, let me give you, explain you through an example. In normal sliding window, if this is our left, if this is our left and this is our right, we would say 1, 2, 3, 4. So 6 minus 2 is 4. So 4 steps, it is within the limit. So we can have it like 8 plus 3 equals to 11, and this is the maximum. This should be our answer, right? But this is not the case with this problem. Why? Because you'll have to take one step left to collect this, then one step right to get back, and then three steps further to get to this. So it is 1 plus 1, 2 plus 3, which is 5, and it is more than the limit of steps which is mentioned. So you won't be able to get 11 as an amount. So this is where this problem is slightly different from a normal sliding window. Okay. So this makes us clear like this is not standard sliding window, but with some tweak we can achieve the same thing. So we need to have a window. So see if our window completely lies on the left side of you where you are standing, or it completely lies on the right side of you where you're standing, then it will be easier thing to calculate the amount. But if your windows lies on either side of you, like left is on left of you and right is on right of you, that is something where we need to concentrate a bit. Otherwise, this problem will become very easy now. So let's say if the window completely lies on left side of you, so here you are standing and it lies on completely on left side of you. So what we need to take care is the left, because right and left is both on left of you. So if this left point is within the limit of the number of steps, then you can add all the fruits, whatever was on the till the left point, right? So it's a simple check like if current position where you are minus left, if it is less than equal to k, then you can have this amount. Okay, if the windows completely lie on the left hand side, this is one of the amount. If let's say your window completely lies on this side, left is here, right is here, so if you can reach till here, so you'll collect all these fruits. So you just need to make sure like this right is within the limit of number of steps of yours. So how you can check that is right minus current position. If this is less than equal to k, then you are covered and you can take this. You'll take whatever is maximum of these two. Like, yeah. Now the case comes off like when the window is on both sides of you. So before looking at that, let's try to understand one example here. Now let's say you have to collect this and collect this. So what would be optimal way to collect this? If I first collect the right one, so I'll have to go three steps forward, which is okay anyways. If I want to collect this fruit, anyways I'll have to travel this much distance. But coming back is something, if we can reduce coming back, number of steps required to come back, this will help us optimize the solution. In this case, for coming back, we require three steps and then we'll collect this one. So for collecting on right side, we have to go less number of steps. So if we try to collect that first, the number of steps required to collect the right and the left would be minimum. I hope you agree. See, in this case, 3 plus 3, 6 plus 1, 7 steps is required. But if you would have done it opposite way, first go here one. Anyway, you have, see, if you want to collect left and right, anyways, you have to go one step right, three steps left. But you have to travel back where you were. So that is one of the crucial point. If you go here, then you need to come back one. If you go here first, then you need to come back three. So which is smaller, this one? Why? Because while going right, the right fruit is closest to you. So I hope this makes sense. So for whichever is closest to you, you try to go that way first, so that coming back requires less number of steps. So third case is when windows lies on both the side, then whichever is minimum, whichever is close to you, like right minus current position or current position minus left, whichever is less among these two, you need to take that. So this is for coming back. And anyways, like whatever is your right and left, that you have to cover to collect those. This minimum we are taking for reducing the steps for reiteration. So this you have to take minimum anyways. And apart from this, to collect all the all the thing on the right hand side and all the amount on the left hand side, you will have to have this 1 and 2. So minimum of this plus minus current position plus current position minus left. So if you see plus current position minus current position cancels out. So you remain with a right minus left. So if we just take care of these three cases, like if these are in the number of your steps, then we are good to go to write our sliding window code. Yep. Let now I'll just try to write, and this will be a big offense solution. I'll write the code. I'll explain it there as well using these, and we'll explain time complexity as well after writing the code there, and we'll see like if there is anything else which we need to explain. I will do so. So let me move to write the code. So we'll start as, we'll say our left is 0 initially, and then right is also at 0. We'll have an answer which is 0, and let's say right starts from 0 and right will go till fruit's length. So we'll have it in an, I think with this logic you can code yourself as well, but if you want to continue, yeah, you can. I'll write the code in Java. Now while our right is less than n, so we'll take a variable called as sum, and we will include this. So this will give us what? This will give us this much amount of harvesting, but we are not sure if we can include this, right? So like standard sliding window, we will write our code here to check if window is a valid one. Otherwise we we will shrink it. We will look how shrink it. Okay, and then after doing this, what we'll do is we'll try to maximize our answer by doing this, like whatever answer is maximum, leave it. Otherwise, if sum gives a maximum, do it. So now this is the crucial step which we had discussed. So while left is less than equal to right, and the steps need to be a valid step, right? So let's call it a step validation function, wherein we need to pass the fruit, we need to pass the left, we need to pass the right, and let's say it will return a boolean for us whether it's valid or not. Now we will have to pass k as well to see if it is in the limit. Now if let's say it is not in the limit, then in that case we need to shrink our window. So we'll say step validation failed function. If it fails, then from sum we'll have to reduce whatever is on the left, right? So from sliding window, only this is the step which is different. We discussed three cases for this, so we'll just take care of that, and then it is normal sliding window then. So fruits of left of 1, this needs to be removed, and then we can increase our left to shrink the window. We missed increasing the right here. Right has to increase every time, and while this is the case, keeps doing that, and some gets reduced, some getting updated. No, some is not getting updated. So let's declare this sum outside, and we'll keep incrementing the sum here, and this is it as part of uh, overall function. We'll define the step validation field function. From here we can return the answer. Now let's write red boolean step validation failed will be, it's a fruit, so fruits and left and right and k. Right. For first case, it was uh, current position minus left, right? So we need our current position as well, where we are. So let me pass my current position, which is start position. Start position. Start position. So in first case, what was mentioned there was like if complete window is on left side. So in that case, the steps was uh, start position minus left. Okay, and steps required if complete window is on left. And how do we figure out like complete window is on the left? If the right is on the left side of current position. So see, if windows right is on left of current position, so this indicates like complete window is on left. Okay, so this would give us like for that. And see, if windows left is on right of current position, this indicate like complete window is on right. right? And if this is not the case, then else part is there. And if this is the case, then we calculate, let's say, some variable, uh, right minus start position. And if this is also not the case, when the window is on both the side, how we said, like in steps, would be minimum of this current position minus left this, or right minus current position, and plus I had written in my tab, the case was minimum of this plus right minus left. So, oh, so if if what I said, right is on the left, so if right is less than equal to start position, so it means it's on the left hand side, and we calculate the steps required, and this if this is within k, we will return true. So return if this is less than equal to k, otherwise else if the window is on the right side, so if left is greater than equal to the start position, then let's calculate the position again. Variable name could be better here. It on right. So again, return. Okay, we had returned in earlier steps, so it won't go in this if that is true. So we can include an equals here as well. So if this is within the limit, then also return true. Otherwise, let's calculate the steps this way, and if this is less than equal to k, then also return true. If steps is less than equal to k. I hope this makes sense and this code runs. Okay, okay, my bad. I silly mistakes. Cannot find this. Okay. Okay, I've given it a start position and using it as current position. And line number 33. Okay, let's see. Wrong answer. Let me see why. Left is just an index. We need to take roots of left of 0 will give me the position, and similarly uh, here this should be fruits of right of 0 will give me the position again. Then here same thing, fruits of left of 0, fruits of right of 0, fruits of right of 0, roots of left of 0. I hope it should work this time. A wrong answer. Condition. On fail, we have to return true, like it failed. Then only we are shrinking. So actually, like here, like if this steps is within the limit, then it is valid. But in our case, we need to return true when it is invalid. So what we have to change here is if this exceeds k, if this exceeds k, if this exceeds k, fail again. Okay, so this right and left, we have not taken care. This has created a little roots of right of 0 and roots of left of 0. Hopefully this should work now. To submit it and see if it is within the time limit. It is. So now if you see the time complexity of this, let's see. You see like we are moving our left and right only once. It is increasing one by one. And in this also like it's a calculation of addition subtraction, not parsing of any array. So we can consider this as constant, and this is big of n, so complete solution is big of n. And